Morning, guys. The notes are nice and quick today. We are in section 3.3, and we're going to talk about proving that lines are parallel. So for this, we're kind of going backwards from where we were. So if you think about all the problems that I gave you before, I said, hey, these two lines are parallel. Now what do you know? So if you look at all of these postulates that we're talking about, they all have the word converse in them. And if you remember back from chapter 2, P then Q is our conditional statement, and the converse just switched that around. So if you read these postulates, they're going to be what we've done switched around. So the first one is the converse of the corresponding angle postulate. And this says, if two lines are cut by a transversal and a pair of corresponding angles are congruent, then the lines have to be parallel. So let's draw this out. If two lines, so we got two lines here, they're cut by a transversal, and a pair of corresponding angles are congruent. Like if I tell you this angle here and this angle here are the same size, then you can say, hey, I know these two lines have to be parallel in order for those two things to be congruent. So this is working backwards. I'm going to give you things like this is 70 degrees and this is 70 degrees, and you're going to say M and N have to be parallel. So if you look, we have 4 of these, just like we had 4 going forwards. The second one is the converse of the alternate interior angle postulate, and this says the same thing. If two lines are cut by a transversal and a pair of alternate interior angles are congruent, then the lines are parallel. Alternate exterior angle postulate says the same thing. If two lines are cut by a transversal and a pair of alternate exterior angles are congruent, then the lines are parallel. Now, same side is our only different one, so this one looks a little different. And this says if two lines are cut by a transversal and a pair of same side interior angles are, oh wait, this is a typo, are supplementary, then the lines are parallel. So your problems are going to look something like this. In this case, I gave you 2 pieces of information, and you need to prove that these lines are parallel. So I gave you that L is parallel to M. So these two here we know are parallel. And then I also know angle 1 is the same size as angle 3. We need to prove that R and P are parallel. So we're going to make a proof. Remember, you need a statements column and a reasons column. First one should be nice and easy. So I told you L is parallel to M. That was given to us. But then also I told you angle 1 is congruent to angle 3. I know eventually I got to get to R has got to be parallel to P. Okay? So let's take a look at what we know. If we go back to our picture over here, if I know that L and M are parallel, I know a couple things about angle 1 and 2. I know that angle 1 right here and angle 2 right here are corresponding angles. So because those two are parallel, the blue lines that I have here, I know angle 1 has to be congruent to angle 2 by corresponding angle theorem. And then, if I know angle 1 is congruent to 2, and angle 1 is also congruent to 3, remember we can cut this middle stuff out right here, and I can say angle 2 has to be congruent to angle 3. This guy and this guy. And this is by the transitive property. And remember, we're doing with congruence, so transitive property of congruence. Now, if we look here, I know that these two right here and right here are exactly the same. they touch one of each of these lines that we're trying to prove are parallel. So what do we call these guys right here? Hopefully you said alternate exterior angles, and we're going to use this right up here, the converse of the alternate exterior angle postulate that says if these two are the same, which we know they are, right here we have them, then we can say these two lines have to be parallel. So our reason over here is the converse of the alternate exterior angle theorem. Okay, we'll do more practice with this when me and Mrs. Carroll are here. But today you're going to do ones like this. What postulate proves that R and S are parallel? So these guys here, we're trying to prove are parallel. So that makes this line here our transversal. Okay, don't know why this keeps moving. Nope. So if I tell you 1 and 5 are congruent, so 1's right here and 5's right here, why, if I tell you 1 and 5 are congruent, would those two lines be congruent? So take a look at all of our possibilities. Take a look at our angle relationships. Those two angles are alternate exterior angles. So we got to use this guy again. He's a popular one. So I know that by the converse of the alternate exterior angle theorem, that if those guys are the same, then R and S has to be parallel. Let's look at another set of these. What if I tell you 3 and 4 add up to 180? Well, if we look at these, they are on the same side of this transversal. So by the converse of the same side interior angle theorem, we know that those two lines have to be parallel. Now this one's a little trickier because I tell you some stuff. The measure of angle 4 is this, the measure of angle 8 is this, and I tell you x equals 5. So all we got to do is a little work and plug stuff in. So the measure of angle 4 is going to be 13 times 5, take away 4. 13 times 5 gives you 65. If you take away 4, you end up with 61 degrees. So angle 4 right here is 61 degrees. Now we got to do the same thing with 8. So the measure of angle 8 is 9 times 5 plus 16. So 9 times 5 gives us 45. And if we add 16, we end up with 61. So this guy up here is 61 degrees. So if we look, angle 4 and angle 8 are alternate interior angles. So this postulate up here says if two lines are cut by a transversal, which we have, and a pair of alternate interior angles are congruent, they're both 61 degrees, then the lines have to be parallel. So for this one, it's going to be the converse of alternate interior angle theorem. So for all of these, anytime you're proving lines are parallel, you have to use the converse of the theorem, which says if angles are equal, then lines are parallel. And the last little bit here is the parallel postulate. So remember, this is something we're not going to prove. This says that if I have a point P not on a line, then there is exactly one line that is parallel to the line I already have. So draw any line in space. Say I got a line here. And then I have a point P that is not on this line. This says there is exactly one line that is parallel to L that goes through that point P. Which, if you think about it, there's only going to be one line like this that is parallel to this one. Any other line that I draw through point P won't be parallel to it because it'll have a different slope. But that's all that postulate says, and we won't actually need that until later this week. So you have a couple things to do. You need to show the sub your notes. She will in turn give you a worksheet. This worksheet is due before you leave today. if you get done with that worksheet before class ends, work on IXL. You have 2 more today that were below this video on Classroom, so that gives you a total of 5 so far. This is all I'm going to give you are these 5, and they're due next Tuesday. Okay? If you have any questions, make sure you write them down, and me or Mrs. Carroll can answer them when we get back tomorrow. Hope you guys have a good day.